Okay, so I think I'm on slide 9 at this point, or I'm started the third page. So, and I have 4 per page, so that tells me probably 9. I'm good at math. Anyway, that slide is marked perineurium and endoneurium. And this is really just referring to connective tissue layers that are around either individual axons and around groups of axons. So we have that. Let me think. Do I want to mention this now, or do we come back to it? Yes, we do. Okay. I was afraid I'd left something out, but it comes up later on. All right, so we have neural pathways and circuits. My printer is getting low on ink, but you can see that slide right there. And we're going to talk about these different circuits. And you can see in this first one, I want you to pay attention to where it is beginning. You see you got a single neuron coming in, and look at all of those pathways out. A single input produces a huge output, and that is what we would refer to as a divergent pathway. And then you can even, in the second example, it's divergence into multiple pathways. So a single input can produce many different kinds of responses even. And so that's divergence. And when we talked about the autonomic nervous system, actually the first part of the second exam stuff, so we don't even get to it before exam 1. But when we talk about the autonomic nervous system, we'll talk about one of the systems is very divergent. It has a very widespread effect, and the other one is more focused. Sympathetic is more divergent. Okay, so you can have a single sensory input that produces many outputs, and that's divergence. And then you can have the opposite, which is convergence, where you have many inputs that are resulting in a single output. So you can have many inputs coming in, resulting, you respond in the same way to many different stimuli, is what we're saying. So then that's convergence, divergence, or convergence. Now, the other thing that we have is we have something called an oscillating pathway. Now, remember, so what we have, let's see if you can see this. You can see that we have inputs in, and when they get to producing an output, it circles back and produces it again, and it circles back and produces it again. And I mentioned that the second function of the spinal cord was locomotion, and I'd said that involves a oscillating pathway, or it's where you get started strolling along and you just keep on strolling. You don't have to think about it. What's something else you don't have to think about? You can think about breathing, but you don't have to, right? It's another, as soon as tidal, what we would refer to as tidal volume, you're going along breathing, and you don't even have to think about that. It happens. It regenerates the muscle contractions associated with breathing. It just happens on its own. So these are pathways that once they're started, they continue on their own. All right. So we have something when we talk about ascending and for that matter, descending pathways in the spinal cord. And what have I done? I've jumped to slide 11, the third one on this page. So it says spinal tracts ascending. And so it ends up, if you know anything about your brain, you probably know that the left left side of your brain controls the right side of your body, and right side of your brain controls the left side of your body. And where does this happen? This crossing over happens in the spinal cord. And so this is what we would call contralateral. So you have signals coming up from the left side going to the right side, and signals coming up from the right side going to the left side. This crossing of these pathways that cross over are what we call contralateral. Now, not all pathways cross over. Most do, but not all. And if they stay on the same side, they are, what do you call it? Ipsilateral. So ipsilateral pathways stay on the same side. They're not as common. Now, what is truly remarkable when you think of cells, and a nerve is nothing but a really weird looking cell, right? So when we think about, if I'm sitting here and you're sitting there listening with bated breath, you're sitting there listening to me, this goofy dude who gets even more goofy when he's on his telephone, sitting in his room by himself. Anyway, as you're listening, if I mention your toes, you say, oh, I can feel my big toe. All of a sudden, you're aware of your big toe. And there's a reason for that, which we won't go into now. But how many cells, neurons, are involved with you feeling your big toe? 3. 3 cells. 1 from your big toe into the spinal cord. Then an interneuron that goes up, and that's your first order neuron. Then an interneuron that extends up, a single nerve that extends up from your spinal cord to a location in your brain, a special location in your brain called the thalamus. And then there's a third one that goes from your thalamus to the surface of your brain. Now, it ends up, the thalamus is where later on we'll talk about how inconsequential information is blocked right there. You don't have to think about the fact that you can feel your toe unless I mention it. And then all of a sudden you can feel it because your thalamus lets the neuron pathway continue on to the surface of your brain. So you have first order neuron from your toe to the spinal cord. Second order neuron up your spinal cord to the thalamus. Third order neuron from that portion of your brain, sort of in the middle of your brain, out to the surface of your brain. That's the third order neuron. 3 neurons in that ascending pathway. And it crossed over in most cases. All right, so we have these spinal nerves, and I said they can look a lot like a spider web, a plexus. So we're right here, and I had said, hopefully you can see that. Anyway, I don't know whether you can or not, but it is slide number 12 if you're playing along. It's called plexus, and so basically it's networks, sort of tied together networks of spinal nerves. You have a cervical plexus and a brachial plexus here up in your shoulder, brachial meaning shoulder, cervical meaning neck. And then you have plexes that are coming out down through that lower portion of your vertebral column, this network of neurons. You have a lumbar, sacral, and coccygeal plexus. And so when these spinal nerves emerge from the spinal cord, they form these networks. And that's what we're talking about. So it's on the outside of the vertebral column. You see these plexus. And this is probably one of the dissections that I've eliminated, or is one where we go in and we find I think. We'll see. Maybe we'll do it. Yeah, or maybe I'll do a demo. I'm not sure what. But you can see these networks of nerves coming out in the shoulder region as well as down in the lower portions of the vertebral column. Okay, so where are these things going? Okay, I'm going to stop right here. We'll come back and we'll talk about, no, I'll talk one more. So we have dermatomes and also myotomes. Okay, and we have our hero here, and it ends up, it ended up when I got this off the internet, it was some medical student who decided to go to a Halloween party showing dermatomes, and it's your body is sort of cut up into layers associated with each of the spinal nerves. And so this was what he was trying to depict, and these are called dermatomes or myotomes. Derma meaning skin, myo meaning muscles, and it's all kind of the same. It's just these neurons, these spinal nerves that are coming out or feeding information in to your spinal cord. They're from your body does this in layers. So your heart typically doesn't hurt, right? When does your heart hurt? I don't mean love hurt. I mean hurt. When you have a heart attack, right? But when you have a heart attack, oftentimes people say, my left arm hurts or my back. It's because your heart doesn't normally hurt. And your brain says, what's hurting? Must be my left arm. Must be my back. It's the myotomes and dermatomes. That's what we're talking about. And it ends up, it's your heart, So go to the doctor. All right, I'm going to stop right here. We'll come back and we'll talk in detail about reflexes.